At this point, we're only considering taking integrals where really you just have the tool of reversing the power rule or undoing the power rule. There are a number of different techniques that we'll learn about different ways we can take integrals depending on the circumstances. Again, the assumption is that all you have at your disposal is how to undo the power rule. So one example where you might have to employ a trick, so to speak, would be something like 2x minus 3 squared dx. And this doesn't give us we don't have any access with it in terms of the power rule, but we could just expand this instead. Right? And we would end up with the polynomial 4x squared minus 12x plus 9 dx. And then we could just integrate this. Right? So this will become, when we integrate, 4/3 x cubed minus 6x squared plus 9x plus c. Right, so one option is just to expand something and then integrate using by the power rule. We could see something like this. We've got the integral of x squared plus 3x plus 1 over x to the fourth, right? Something like this may have come from having to do a quotient rule. And one option is simply just to break this up into 3 parts, right? Instead of making it real complicated, we can just rewrite this thing as, well, x squared over x to the fourth is x to the negative 2, and 3x over x to the fourth is 3x to the negative 3, and 1 over x to the fourth is simply x to the negative 4. And just by changing its look, we're able to approach it in terms of the power rule. So when we integrate this, well, let's see, this would have been negative x to the negative 1 and x to the negative 2, so minus 3 over 2 x to the negative 2 and minus 1/3 x to the negative 3 plus c. Right, so we just broke it up into individual parts and then integrated it. A final problem that requires an algebraic trick, so to speak, at least at this point, is if we have something like 2x minus 5 times 3x plus 2 over the square root of x. And again, here's just an application of both of these things at one time. First, I'll expand this. So my numerator will become 6x squared, what's that, plus 4x minus 11x minus 10. And each of these is being divided by the square root of x. I can clean this up a little bit more by dividing every piece by root x. So this will become the integral of 6x to the 3 halves minus 11x to the 1 half minus 10x to the negative 1 half dx. And now when I integrate this, this would have come from 5 halves power, so this must have been 12/5 x to the 5 halves, right, because that would be 60 over 10 minus, let's see, this would have been x to the 3 halves, so minus 22/3, and then this would have come from x to the 1 half, so minus 20 x to the 1 half plus c. So again, just applied both rules or tricks to these kinds of expressions. And again, this just gives us access to still think about a problem in terms of the power rule, and then we're going to learn other techniques along the way. In the next section, we're going to look at some examples considering trig identities, so make sure you at least know what the formulas are for your various trig identities, and we'll go from there.